Very good. So, yeah, good evening, everyone. And today we will be studying about Mercury. Let's study about Mercury. What is the peculiarity of Mercury? It is the first planet from the sun, right? So, it's only about 60 million kilometers away from the sun. The distance between Mercury and sun is just 60 million kilometers. And it takes Mercury about 88 days to go around sun once, and one Mercury day is about 58 Earth days long. So it revolves faster than Earth, but it rotates slower than that of Earth. It takes 58 Earth days for Mercury to have one rotation. Then the surface of Mercury is very much like that of the moon. Yeah, look at Mercury's surface and look at moon surface. They're almost similar, right? Yes. Now, Mercury is a heavy planet. Heavy planet in the sense they're not massive, but the density is high. Now, gravity is about one third of the Earth. For Moon, the gravity is one sixth of the Earth, right? But for Mercury, it is one third. The core of Mercury is probably still liquid. Yes, our core is solid, by the way. Now, these are the gases found in Mercury's atmosphere. Mercury's atmosphere means it's nothing like our atmosphere. It's a very thin atmosphere. It contains hydrogen, helium, and oxygen. Very thin atmosphere. Also, it has smaller amount of sodium, potassium, calcium, and magnesium. So, if I ask the question, what are the three abundant gases in Mercury's atmosphere? Let's say hydrogen, helium, and oxygen. Now, there is this question that how can there be water on a planet that nearly boils in the solar system? So there is a NASA scientist whose name is Thomas Zurbuchen. He notes three possibilities. The first one being there may be reservoirs of water ice in small areas of Mercury's poles. This water could be as old as the solar system. So this is one of the possibility for the occurrence of water ice, because there can be reservoirs of water ice in small areas of the Mercury's poles. And next is comets may have deposited water in it, just like some other systems. Now, the third one is chemical sputtering that could create water from the solar wind and Mercurian rock. So, three possibilities are there. The first one being uh, occurrence of reservoirs, the second one being deposited by comets, and the third one chemical reactions. Now, yeah, because of its close proximity to the sun, the innermost planet Mercury cannot be studied from Earth against the night dark sky. Many astronomers and most people have never seen this elusive planet. That's true, right? We can see Mercury only when it is day, because in night we will be facing away from the sun, right? So if we face the sun, then only since it is ahead of us, then only we can see Mercury. So that is a problem while we are studying about Mercury, because the sun's light is so intense that we won't be able to get a clear picture of the Mercury from Earth. Now, during the daytime, Mercury's ground temperature reaches a blistering 740 degrees Kelvin. Look at this, 740 degrees. And at nighttime, it plunges to a freezing 100-degree Kelvin. So these are the different um, temperature scale range at which Mercury is seen. If it is daylight, because daylight in the sense daylight in Mercury, okay. If it is daylight in Mercury, it is 740 degrees, and if it is nighttime, it's 100 degrees. Mercury has a thin atmosphere to speak of, just an exceedingly tenuous wisp of atoms. Yeah, we have already talked about that, right? The three gases present in which were hydrogen, helium, and oxygen. Yeah. Now, Mercury's rotation axis is aligned perpendicular to its orbital plane. Yesterday we discussed about rotational axis, right? You remember the rotation axis means, for example, for Earth, uh, rotational axis means the axis within which Earth is rotating, right? It has a tilt. You may have studied. It has a tilt and all that, right? So just like that, there is this rotational axis for Mercury, and it is aligned perpendicular to the orbital plane, which means there is no tilt for Mercury's axis, and so there are no seasons on the planet. The reason why we have different seasons is because we have a tilted rotational axis. So during different seasons, when as the Earth is revolving around the sun, at some particular months, what happens? The sunlight is directly hit on the northern hemisphere, and sometimes it directly hit on the southern hemisphere. So because of that, we have seasons. It's because of the tilt of the rotational axis. Like we have different seasons, like summer, winter, fall, etc., and spring. Yeah. Now, although one of the Earth's nearest neighbors, only one spacecraft, Mariner 10, has ventured near Mercury, viewing only about half of the planet's surface. The details, of the other side of the Mercury have not been seen. Anyway, at first glance, Mercury is airless, cratered surface resembles the moon, but Mercury has unique surface features, including ancient intercrater plains, young smooth plains, etc. Yeah, then there is one more thing that relative to all other planets, 4 to its whole size ratio, Mercury has a bigger core. So it's believed that Mercury must have been a larger planet, but since it is near to the sun must have accreted the surface layers of the planet. Here you can see um, a picture of Mercury. It's made of different mosaic. We can see here different, see, 1, 2, 3. Yeah, according to different latitudes, we Mariner 10 got different, high resolution pictures of each of this region, and when they are combined together, we got this beautiful figure. Yes, so yeah, these are the fast facts of Mercury. From mean distance from the sun, this is 5.7 into 10 raised to 7 kilometers, or you can say 0.385387 astronomical units. And its diameter is 4,879 kilometers. For Earth, it is almost 12,000 kilometers. Volume, if we consider volume of Earth as 1, then the volume of Venus is 0.05, sorry, volume of Mercury is 0.054. Now, the mass of Mercury is 3.3 into 10 raised to 23 kilograms. And yeah, these are the different vital facts of Mercury. It does not have any satellite. Yeah. Now let's talk about something called exosphere. What is this exosphere? For example, this Mercury has an extremely tenuous, extremely thin atmosphere with a surface pressure of a trillion times less than that of Earth. So when compared to Earth's atmosphere, um, Mercury's atmosphere is very thin. That kind of atmosphere, like thin and tenuous atmospheres, are called exosphere. Because in Earth's atmosphere, what happens? Atoms collide with each other because they are closely packed. But in exosphere, atoms are not closely packed. So Mariner 10 identified the presence of hydrogen, helium, and oxygen in the atmosphere and set upper limits on the abundance of argon. These elements are probably derived from solar wind. So solar wind, of course, it has hydrogen and helium gases, right? And later, Earth-based telescope observation detected sodium and potassium in quantities greater than the elements previously known. Now, from where did sodium and potassium came? Could be released from surface rocks by their interaction with solar radiation or by impact vaporization of micrometeoroid materials. So the ability of planet to retain an atmosphere depends on, yeah. Why do some planets have atmosphere and why does some does not have? It depends on the escape velocity of the planet. Because if consider larger planets, if the planet is massive, the escape velocity is more. It is actually directly related to or proportional to the mass of the planet. So, what is this escape velocity? It is a minimum velocity with which anything on the surface of a planet can escape to space. It should have a minimum velocity of that much. For example, in Earth's case, uh, if we are throwing a stone, it will come back to Earth, right? But if you throw that stone with a velocity of 11.2 kilometers per second, then the stone won't come back to Earth, but it will go straight and reaches the orbit. Okay, so that is what we call escape velocity. So consider there are some gases, evolved in the Mercurian atmosphere. But if the escape velocity of these gases are, if the velocity of these gases are maybe say some 5 kilometer per second or 6 kilometer per second, and if the escape velocity of this planet is less than that of that, of course the gases will escape to space, right? Now, why do a moon doesn't have an atmosphere, right? So why is that? It's the same thing. Escape velocity on the surface of moon is just 2 kilometers per second. That easily gases can attain. So they'll attain that velocity and will get out of that atmosphere to space. Now, speed of gas, atoms, and molecules, which depends on temperature of the gas, mass of the gas, etc. Yeah, these are the two reasons. If the temperature is more, temperature of these gases are more, which means they'll move faster. More temperature means more energy. Yeah, so these are the different, images. The left figure is Mercury, and the right one is Earth. And if you consider the core of Earth, it is 3,470 kilometers thick, but the core of Mercury is 1,800 kilometers. And the radius, yeah, from radius of Earth is 6,370, while the radius of Mercury is 2,440 kilometers. Yes. Now, there is this big basin on the surface of the Mercury. It is called the Calories Basin. It is at 1,300 kilometers in diameter. We can see the basin here, and this is the rim of it. Rim means, the circular edge of the crater. It's called rim. Now, there is a schematic figure here showing how the effect of the formation of calories basin affected the whole planet. So here the impact happened. Okay. So an asteroid must have come this way and it hit in this region. And so ejector, which means particles will escape from this region to the other regions, right? It will spread since the impact has happened here. So due to this impact at the crest, there occurred a compressive wave, and here in the opposite side, due to this wave, hilly linear terrains were generated. So just opposite to that of the Calories Basin, there are hilly and lineated terrain. It's because of this impact and traveling of that compressive wave towards the opposite side. Now, linear cliffs called scarps, hundreds of kilometers long, were probably caused by the contraction or wrinkling during the cooling of the planet. And here you can see linear cliffs. They are actually hundreds of kilometers long. So during the cooling of the, when yesterday we talked about the formation of planets, and when planets were formed, first it was very high temperature, right? The temperature was very high in those early planets. So while it is cooling, many things happen there. For example, in Mercury, what happened? A linear cliffs were formed. They are called scarps. And these are the properties of Mercury. Let's say, yeah, the orbit. Mercury has a very elliptical orbit. Elliptical in the sense oval shape. Although we say that circular orbits, we say that planets are revolving around the sun in circular orbits, but that's not true. The orbit is actually elliptical. So elliptical means at some point uh, the planet will be closer to the sun, and at some point it will be far away. So it's not like circularly revolving around the sun, but its orbit is elliptical. So perihelion and aphelion means when the planet is closer to the sun in its elliptical orbit, we call it perihelion. And if the planet is away from the sun, the farthermost point in the elliptical orbit is called aphelion. And for Mercury, the perihelion is about 46 million kilometers, while the aphelion is 70 million kilometers. So, Mercury is about 77.3 kilometers, million kilometers from Earth as it's in the closest approach. So, the distance between the closest distance between Earth and Mercury is 77.3 million kilometers. Yeah, now about the rotation. This planet rotates once about every 59 Earth days. Yeah, and rotation slower than that of any other planet except Venus. So these, although they are very close to the sun and they are very small, but don't be fooled by that because they are lazy rotators because they rotate in a very slow pace, both Venus and Mercury. For Mercury, it is 59 Earth days, and there is one more planet which rotates slower than this, that is Venus. Now, as a result of planet's slow rotation on its axis and rapid movement around the sun, a day on Mercury lasts 176 Earth days, which means that see the Mercury is revolving around the sun, right? So since considering uh, 59, it Mercury rotate in its own axis in 59 days and it revolves around the sun, right? And so considering both these motions, yeah, both these motions, a day on Mercury can last to 176 Earth days, which means interval between one sunrise and one sunset. Now, about composition, Mercury is the second densest major body in the solar system after the planet Earth, and its density is slightly less than that of. So, Earth is the most dense planet in the solar system, and Mercury is the second densest material. And Mercury's oh, one second, please. Mercury's smaller massive, and it makes its force of gravity only about a third as strong as that of Earth. Yes, and about the surface of Mercury consists of crater terrain and smith plains and many deep craters similar to those of the Moon. Now, scans of Mercury made by Earth-based radar indicate that craters at Mercury's poles contain water ice. Yeah. So, Earth-based telescopes are there, and radars are there, which uses radio signals sometimes, you may have seen a radio telescope, right? It takes a lot of area, and mostly it is not like an optical telescope where there is a mirror attached. That kind of a system is there. Now, for radio telescopes, they are the array of antennas are kept, and the radio signals are received by this telescope. So one of such study indicated that there exists water ice on the poles of the planet, and the floors of the craters are permanently shielded from sunlight, so the temperature never gets high enough to melt the ice. Although the surface of the planet, uh, the, the light is directly affected, the surface of the planet. I mean, surface of Mercury, if you talk about, the sun's light is directly hit, but in the craters, the bottom of the craters, since there are many big craters, sunlight never reaches that region. So, in that case, the water ice are not melted. It could act as reservoirs, though. Now, what about the temperature? Yeah, the mercury has extreme temperature variation, and it is hotter than that of Venus with less fluctuations. The temperature on the planet may reach 450 degrees during the day. Yeah, about atmosphere, yes, we talked about it. It is dry. It's almost airless, but the atmosphere is very tenuous, and we call it exosphere, right? But Mercury is too small for its gravity to retain any significant atmosphere over long periods of time. And so, what are the gases found in the surface of the Mercury? The first one is hydrogen, helium, oxygen, sodium, calcium, and potassium. Yes. So this is the end of the first slide, which is Mercury. And we will have a look at our next slide, which is Venus. So about Venus, let's have a look at the vital statistics of Venus. Its diameter is 12,104 kilometers. Do you, yeah, it is similar to that of Earth's diameter, which is 12,742 kilometers. See, it's almost similar. That's why Venus is called the twin sister of Earth. So the mass of Venus is 4.8 into 10 raised to 21 tons. And then mean density is 5.25 days. Now the rotational period is 243 Earth days, which means the revolution period is 224 Earth days, which means it will take 224 Earth days to revolve around the sun, And also, it will take almost more period than that. I mean, 243 Earth days for a day in Venus. So Venus is a planet which rotates very slow, and a day in Venus is uh, less. I mean, less than that of an year. I mean, more than that of the year, which means a day. Consider a day in Venus you're spending. It's almost more than a year. Okay. Now the surface gravity is 8.87 meter per second square. For Earth, it is 9.8 meter per second square. And it does not have any natural satellites or ring system. Now, there are some basic information about the Venus. Venus is the second planet from the Sun and is named for the Roman goddess of love and beauty. One more thing is, it is the only planet which is named after a female, Roman female character, that is Roman goddess of love and beauty, Venus. Venus and Earth are often called twin sisters because they are almost similar in size, mass, density, composition, and gravity. Now, why do we call Venus as the goddess of love and beauty? Do you think the surface of Venus is that beautiful? No, it's not
No.
because of that. Yeah. But the thing is, whenever in the morning you wake up, in the eastern sky, you can see Venus. And in the evening sky, evening western sky, you can see Venus. That's why it's also called the morning star and evening star. See, from Earth, if you look at Venus, we can see, a star-like thing, but it's not blinking and also a little bit bigger than that of the stars. That's why it's so beautiful to look at from Earth. That's why, long before we knew about the surface of the Venus, we called it uh, after the name of Roman goddess of love and beauty. Now, Venus is one of the terrestrial planets, those with solid rocky surfaces inhabiting the inner part of the solar system, and its axis is nearly vertical, just like that of Mercury, and its orbit is nearly circular. So Venus does not experience seasons the way Earth and Mars do because of their more tilted axis and more elliptical orbits. Yeah, so just like Mercury, Venus also does not have different seasons because its rotational axis is perpendicular that of the plane. The tilt is very less. Now, a day in Venus lasts 243 Earth days, and that's how long it takes Venus to make one rotation. While a year in Venus is shorter at just 24.7 Earth days.
Excuse me, miss.
Yes?
Miss, can you go to the previous slide?
Yeah,
Thank you.
no problem.
Miss, you can go back to the other slide.
Okay, thank you. So here, there is this question that can life exist in Venus? If Earth and Venus looks like together, is there a possibility of life on Earth? But the answer is it's hard because anyway, Earth-like life, we cannot live in a system like that. Maybe any other kind of things, actually there is no life found yet in the surface of Venus, but our kind of life means,
Ma'am, ma'am,
yes.
ma'am, some scientists are saying that that life exists on Venus because they saw like in the atmosphere, like some
No,
places
no,
of the
it's
atmosphere.
actually, yeah, we'll talk about that. But actually, there was a sign of phosphine in the atmosphere of Venus, but that was a fault alarm. Uh, and later we understood that it's not from any living object. So that theory was actually a wrong idea. And later they moved on. Yeah, thank you. And now, yeah, Venus is the hottest world in the solar system. It is the hottest planet. Even though Mercury is closer to the sun, Venus is the hottest planet in the solar system. Why? Because the atmosphere of Venus is very thick. That's why it's very. We know that when it is cloudy, yeah, the temperature rises, right? Because there are in greenhouse gases present in the atmosphere of Venus. The global warming effects are there, and also, yeah, we'll talk about there is sulfuric acid. If sulfuric acid gaseous form, it is present in the atmosphere. Also, carbon dioxide. These are actually greenhouse gases. So, if the presence of greenhouse gases are there, there is probability of global warming. So that's why Venus is said to be the hottest planet in the solar system, and it has coronae or crowns, a ring-like structure that ranges from roughly 95 to 360 miles kilometer wide. Now, the air pressure in the surface of Venus is extreme. See, if the air pressure in the on the Earth is considered as 1, then in Venus it's actually about 90 times higher than the pressure at sea level here. Please stop scribbling in the screen. And then, yeah, the surface atmosphere of Venus is 90 times, um, having 90 times more pressure than that of Earth's surface pressure. So, in other words, the pressure on Venus is about the same as that of water pressure on Earth, about half a mile. So, consider we are in the ocean, 1 kilometer, that is 1,000 meters uh, below the ocean. Okay, you know that whenever we go below the ocean water, then the pressure increases. So, the pressure of um, that much, which is 90 tons. We can't survive that kind of pressure. We'll actually report in that kind of pressure. Now, about the volcanoes, there are more volcanoes on Venus than in any other planet in the solar system. So, the volcanoes in this surface, it's actually most of them are active ones because they continuously emit lava, and that also increases the vulnerability, the the extreme weather in the Venusian atmosphere. Next thing is, Venus doesn't have an magnetic field. Earth does have a magnetic field, but Venus doesn't have, or it does not have a satellite. Now, Venus has a highly pressurized atmosphere as well, consisting mainly of carbon dioxide with clouds of sulfuric acid, and scientists have only detected trace amounts of water in the atmosphere.
Excuse me, ma'am.
Yes.
Ma'am, can I tell a fact, ma'am, about Venus?
Actually, you can talk about that after the lecture, okay?
Okay, ma'am.
At 6:30.
Okay,
Yes.
ma'am.
You can type it in the chat section so I can maybe discuss about that. Thank you. Now, these are other basic information of the planet Venus. So, except for the sun and the moon, Venus is the brightest object in the sky. That's why we called it after the goddess of beauty and love. And it's often called the morning star when it appears in the eastern sky during sunrise, and in the evening, it's seen in the western side when it is sunset. And there are other basic information regarding Venus, that in ancient times the evening star was called Hesperus and the morning star was called Phosphorus or Eosphorus or Lucifer. in ancient world, people then could not recognize that both this morning and evening star are the same. So they called them by different names. And later, as astronomy flourished, people became, aware that these are not different celestial objects but same.
Miss,
Now,
hello.
yes,
Miss, can you go to the previous slide?
this one.
No, Miss, even before that. Yes, thank you.
Okay,
Yes, Miss, now you can move on.
okay, thank you. So here, yeah, when Venus passes between the Earth and the Sun, and the planet appears to have phases like Moon. Actually, this was one of the reasons why, in previously it was there was a doubt, or the theory of heliocentric emerged, because if we are considering that the Venus is revolving around Earth, then there is no need of formation of um, phases, right? Just like Moon, but it had phases, and it's because it is revolving around the Sun, and Earth and Venus, they are also rotating. That's why we can see it. So Venus passes between Earth and the Sun, and the planet appears to have phases like the Moon. And here you can see a photo collage of the planet Venus as it travels from our side of the sun to the farthest side. When it is in the farthest side, we can see the full Venus, while if it is near to us, we can only see a part of Venus, like the crescent. Now, yeah, Venus is rare among the planets in that we can see it froze in front of the sun. Yeah, just like that of Mercury. When consider sun's disk, and sometimes we can see it passing through, passing like a small dot. It is passing through the disk of the sun when we are looking from Earth, and that event is called transit. When Mercury is passing between Earth and Sun in the Sun's disk, we call it transit of Mercury. And when Venus does that, we call it transit of Venus. Just because, Venus and Mercury are uh, in front of us, ahead of us, in near to the Sun, we can see this. But we cannot see the transit of any other planets. But consider this is a phenomenon just because we are looking from the Earth. Consider we are looking this from Jupiter, then we could see the transit of even Earth and Mars. Now, yes, about the motion. Yeah, Venus circles the Sun once every 224.7 days in a counterclockwise direction, the same direction as the other planets in the solar system. So it circles the Sun every 224.7 days. But Venus rotates on its axis the opposite way that most planets rotate. This is a funny and interesting thing. Venus rotates on its axis the opposite way that most planets rotate. That means on Venus, the sun would appear to rise in the west and set in the east. We know that in which direction, we see the sunrise in eastern sky, right? It's because Earth is revolving from, I mean, rotating from west to east. From west to east, Earth is rotating. That's why we can see sunrise in the east. But Venus is rotating from east to west. So it rotates backwards, uh, which means it's clockwise. So, which means the sun will rise on the western sky. Now about the magnetic field of Venus, that yeah, it does not have an internally generated magnetic field. There are many reasons why we Earth has magnetic field. We'll study about that tomorrow when we deal about Earth. The thing is, um, there are many reasons why Earth has magnetic field that we'll discuss, but we could not find magnetic field for Venus. Now, one of the reason is it's because of its slow rotation. Consider 243 days. Something is rotating on its own in 243. It's very slow motion, right? Even sun rotates in 25 days. So it's one of the reason is this slow rotation, and it's predicted lack of internal thermal convection. Any liquid metallic portion of its core that could not be rotating fast enough to generate a measurable global magnetic field. So there is nothing in Venus in liquid form in the different sections of Venus. Because of that, uh, Venus doesn't have a magnetic field. Yes. Now, despite the absence of large protective magnetosphere, the near Venus environment does not exhibit a number of similarities with planets such as Earth. For example, the latest surprising example is the evidence of magnetic reconnection on Venus-induced magnetotail. Yeah, we'll discuss about that. See, Earth has different phenomena. For example, aurora. Auroras are formed in the polar regions of Earth because the solar wind interacts with the magnetic field of Earth. But since there are no magnetic field presented in Venus, this is not seen in Venus. Now let me tell you about magnetotail. Yeah, sorry. Let me take a picture of it. So sometimes it's not seen every day, but at some in rare events that there exists a sheet of electrons and ions enveloping the Venus in a height of 150 to 300 kilometers, and it can expand to space like a tail. So it's like exceptional deformation occurs on the planet's night side, not in the day side, but in the night side. When the solar wind, the flow of charged particles in the sun nearly comes to a stop. Because see, continuously solar wind is blown to every direction, right? So when it is interacting with the atmosphere, but not the magnetosphere, but the atmosphere, because of this, charged particles are which are around the Venus expand to space like a tail. So that is called the Venusian magnetotail. Yes. So the Venus atmosphere, 96.5% of the volume of Venus atmosphere is carbon dioxide, and 3.5 is nitrogen. And there are other gases, but in trace amounts.
Ma'am, these pictures are very blurry, so we can't actually understand anything from it.
Yeah, I'll tell you about that. See, carbon dioxide in Venus, carbon dioxide is the gas which has more volume. I mean, 96.5% of the atmosphere of Venus is carbon dioxide. On Earth, 78.1% of the atmosphere is nitrogen. Nitrogen is the abundant gas in Earth's atmosphere, and carbon dioxide is the abundant gas in Venusian atmosphere.
Excuse me, ma'am.
Yes.
Ma'am, I can't see the screen.
Okay, can you please check the connection is fine?
Okay, ma'am.
Yeah. Now the exterior and interior traits of Venus. See, these are the exterior and interior traits in the sense. See, if this is Venus, this is the crust, and it has a mantle and a core, just like that of Earth. It has a crust, mantle. Below the crust, there is mantle, and inside there is core. And the surface of the crust, there are craters, mountains, and volcanoes present. Now, regarding researches occurred in the Venus, in 1962, NASA's Mariner 2 came within 21,600 miles of Venus, making it the first planet to be observed by a passing spacecraft. And in 1967, it was Mariner 5, which went for studying Venus. And in 74, it was Mariner 10. There was this satellite called Vega 1 and 2, and it was sent towards Halley's Comet in 1984. Also flew by Venus and released decent capsules. Decent, data was retrieved by these satellites, and several of these probes successfully reached the planet's surface. So this Vega had different spacecraft, small ones, and it is sent to reach the surface of the moon and Venus, and several of these capsules actually successfully reached the surface of the Venus. And in 1978, there was this Pioneer mission. It sent 4 probes to the surface, while the remaining craft explored the atmosphere. In 1978, Pioneer Venus 1 and orbiter measured the upper atmosphere for 14 years. And Venus is one of the planet to which a lot of satellites have been sent. A lot of satellites by Russia and US has been studying about the planet for a very long time. And there was this Magellan probe launched towards Venus in 1989. It transmitted radar images of the planet from 1990 to 1994. In 2005, the European Space Agency launched the Venus Express spacecraft on a mission to Venus, and it is equipped with instruments designed to study the structure, chemistry, and dynamics of the planet's atmosphere, particularly its hurricane-force winds and its cloud system. It's very important to study about the cloud system of Venus because, see, when there exists more greenhouse gas in the atmosphere, uh, you know, a very difficult for us kind of atmosphere can rise. And in Earth, we know that the amount of carbon dioxide is increasing. After the industrial revolution and since the vehicles are emitting the greenhouse gases, and then there are industries from which these greenhouse gases are produced. So the level of carbon dioxide in our atmosphere is being increased day by day. So it's very important to study about the surface atmospheric characteristics of Venus. So there was another satellite called Venus Express. It also carried the first infrared instrument designed to study the planet's surface at infrared wavelength, making it possible to detect active volcanoes if they exist.
Excuse me, ma'am.
Yes.
Ma'am, can you go a little bit back?
Yeah. This slide.
No, ma'am. One.
is this one. The slides will be sent to you actually. So no need of going back to the slides. All these slides will be sent to you after the 5-day session. Okay.
Ma'am, via email
Miss,
or
and will
WhatsApp?
be the recording sent?
Yeah, I think,
Yes,
yeah.
ma'am, it will be. I asked
Yeah.
for the recording because I missed the last class, so
Okay.
they said yeah.
Yes. So the recorded section will also be sent to you. Thank you. Now, there are some trivia details regarding Venus. It is the global warming on Venus has caused by the surface temperature to rise nearly to 900 degrees Fahrenheit, enough to melt lead. Now, winds swipe across the Venus at super fast speeds. It can reach up to 450 miles an hour. Think about that. And in its middle cloud layer, these Venusian winds are faster than the speediest tornadoes on Earth. So continuously, its temperature. I mean, wind speed is really high. It's like tornadoes, cyclones happening every time, and in the equator. And sometimes, because of its bright nature, it's often mistaken for UFO. UFO means unidentified flying object, just like ET and all. ET, that spaceships and all. Now, we talk about different planets. For example, Mars is the Roman god of war. Neptune is the Roman god of ocean, right? So, considering that, the characteristics or features of Venus are feminine. So Devana Chasma, which means features in the sense mountains and volcanoes or valleys, etc. So this Devana Chasma is a canyon. It was named for the Czechoslovakian goddess of hunting. The Chondi Chasma named for the Bengali goddess with animals. So the canyons are named, mountains are named in female characters. Then Copacabana Mons, named after the Inca lake goddess. Then the irregularly shaped crater called Pachera were named after the famous women, including Burns Pachera, named for Leo Tolstoy's wife. Yes, so we have completed our, you know, two two planets discussions. The first one we discussed about Mercury, right? So
Mercury.
yeah. So
Okay, ma'am.
okay, everyone. Bye.